All right, so first things first, let's just get the data inside. So for the data, I'm just going to use a mice package. So mice package can be installed like this, install.packages, then just call mice, right? Just call mice. Um, so I have already installed the package, so I think I already have, yeah, I have already installed it, so it's already here for me. So once you have installed it, you just need to point to that library, call this function, right? Then point to the library and it will create the check mark. If you don't run the library command, it's not going to be activated for this instance of the code. So you need to, after installation, you have to point to that. So for the data set, like I mentioned, I'm going to use a data set that is inbuilt within this mice package. So that's going to be, I'm just going to create a name for the data. Input data is equal to, the data set name is called NHANES, right? It's basically like a healthcare data from the ministry. So I'm just going to copy over this data into my new variable. All right, so let's just take a look into the data. Just click this small matrix icon. We have 4 variables: age, BMI, hypertension, and cholesterol. So ages looks like it's for the babies, and ages starting from 1 to 3. They have captured the body mass index, hypertension, and cholesterol for the babies, and this is the data we have. The problem with this data is basically we have some not applicables here. See here, there are some not applicables. So for treating the not applicables, there is a lot of different ways. There is like deletions, pairwise deletions, listwise deletions. Right now, what we're gonna do is imputation. Right, deletion is gonna cause you loss of the record. So in imputation, it's gonna overcome that problem. So what imputation is basically going to do is it's going to replace these not applicables with some statistical values, right? So in our first method, what I'm gonna show you guys is this in the simple imputation. I'm gonna show you guys how we can replace those not applicable values with. Sorry, let's just open it back. The first one, I'm just gonna show you guys how we can replace these not applicable values with the mean of this whole column, right? Let's say for example the mean that we're gonna have here is like 25 or 20 or something. That value is exactly going to be replaced with all these not applicable values, right? And that's it. Likewise for cholesterol also we'll do that. Hypertension, if you see here, it looks like it's a binary value. So for hypertension we cannot do that, and it's not advisable to do that. So for hypertension and these kinds of mixed values, that is exactly when you have to use chained imputation. That's the advantage of using mice, right? So let's go ahead and start it over. So first things first, let's do the summary and analyze the distribution of these data. Let's go ahead and just call the summary and run it. Oops. If you take a look here, there is age, that minimum is 1, the first quartile is also 1, the median is 2, mean is 1.76, third quartile is 2, max is 3. And for the BMI, so age doesn't have any not applicables. The beauty of this command is it's going to show us if there is any not applicables, it's just going to show it right there. You see here at the bottom. BMI has 9 not applicables, hypertension has 8 not applicables, and cholesterol has 10 not applicables. It's cholesterol looks like it's crazy because the total records itself is just 25, and out of that almost half of it is not applicables, right? So it's very not healthy data set. I mean, like, not clean data set. So we need to make sure to impute these values. Hypertension, if you see here, keep in mind that for any binary values, we cannot create like a distribution like this with minimum, first quartile, median, like that, right? It doesn't make sense, right? Because there's only going to be either this or that, like 1 or 2, or 1 or 0, or male or female, or like yes or no, right? That's how binary distribution is going to look like. You don't want it to necessarily distribute like a continuous variable. So what we need to make sure is before we run this command is conversion, right? So let's convert or cast this data into a factor. By that, what I'm doing is I'm just converting from the continuous into a uh, binary. So let's just go ahead and say this as dot factor. It's going, this function is basically going to convert this hypertension variable into a factor, and it's going to reassign it back to the actual data itself, right? So like as dot factor, we have as dot numeric and as dot text and bunch of different variables, but for our use case we're just gonna say as dot factor. So now if you run the summary command again, you see here, now this is exactly how it should look like, right, compared to the previous command, in which it showed all the distribution for binary values, which is not right. Now it just shows the frequency of the binary value. What is the frequency of ones? It's 13. What is the frequency of twos? It's 4. And the not applicables, obviously, right? So now we have analyzed the distribution right now. All right, for so simple imputation, what we need to do is we need to replace all the not applicable values in our BMI and cholesterol with the mean value, right? So how do we do that? So it's straightforward. So just call the data set, open the data set, go inside the BMI function, right? And then we need to here pass all the not applicable indexes, right? So you see here, I just showed you guys what all the not applicable values within my hypertension, but we need to actually point it to my BMI. So there is a command called which is really an amazing command. It's gonna pass us all the indexes, whatever is qualifying within this logical. It's gonna execute a logical function inside. So whatever is a true, it's gonna return those exact indexes, right? And that's exactly what I need on my left hand side. So on my right hand side, what I'm gonna basically do is I'm gonna just make like a mean command, mean of my BMI, right? I'm just gonna put it over here, right? So hang on with me, I still need to make some changes. I just wanted to show you guys high level skeleton of how the code is gonna look like. So in the which command, I need to pass what are my not applicables and what are not my not applicables. So first I need, how do I find that? Using is.na. So is.na is gonna help me find all the not applicable values. It's gonna return as true, right? I just gonna pass it over here. So if I just execute this, so it's going to show all the not applicable values within the BMI column, right? So just look into the last piece here, and let's take a look into the data set. You see here, the first is not applicable in my BMI, third is not applicable, fourth is not applicable, sixth is not applicable, 10, 11, right? First, third, fourth, whatever this, like, it's gonna, wherever there is not applicable, it's gonna return as true, and the clean records, it has a value, it's gonna return as false. All right, so now I have captured this thing. So if I run the which command alone, I'm gonna show you guys how it's gonna look like. You see here, it is returning all those indexes wherever I need to change. So this command, at this brace, we're gonna have 1, 3, 4, 6, 10, 11, 12, 16, 21, right? So only for these indexes, we're gonna replace the mean into the not applicables. So if I run the mean command, let's go ahead and run it. It's gonna throw us not applicables, right? Because obviously the data is not clean. So that's the reason. So how do I get over this problem? I need to remove the not applicables before I calculate the mean, right? There is this command called na.remove. So I need to turn it on, make it as true, right? All right, so now it's all set to go. So let's just go ahead and execute it. Now let's go back. Now it has, the command has run. So let's go ahead and take a look. You see here, 26.5625, that's the mean of my BMI column. So it's been replaced all over. So the BMI column is now clean, right? Let's just repeat the same step for the cholesterol as well. So it's again continuous, right? So let's just go ahead and do that. For hypertension, I'll come to that. So let's just do it for the last column, which is cholesterol, right? So just go ahead and do that. Cholesterol is, just make sure we are replacing the mean of the cholesterol or not some other column, right? Cholesterol, and let's go ahead and do it, right? So if I go here, cholesterol is also clean. So cholesterol and BMI age, we have 3 clean columns. Hypertension, we need to come to that, because for hypertension, I don't want it to hard code a value. Right now we're just hard coding the mean into BMI and cholesterol wherever that's not applicable, right? But I don't want to do the same step for hypertension. I don't want to take something like, I don't want to make a mean of this column, right, and then replace it with here, which is like it's not the right thing to do, because hypertension is a binary value. It can either be 1 or 2. Maybe I think 1 means the patient has a hypertension, and 2 means the patient did not have a hypertension, or maybe 1 means like low hypertension, or 2 means higher level of hypertension, right? uh, I don't want to create 1.5 or something like this around here, which is gonna mess up the whole logic of this column. So that is the reason we are going to the step number 2, that is called imputation with mice, right? So mice has a beautiful function called mice again. So that function is going to help you to do the chained imputation by applying a lot of different statistical functions to specific columns in your data set, right? So let's first go ahead and create like a function, my imp, right? My imp is my function name. You can call it any other name, it's okay. So mice is the function name. If you see the arguments, uh, I can actually walk you guys through the arguments. So let's just go search in my help. It's okay, just run it. Yeah. So it's, if you see here, these are the different arguments this function is going to take. So first you need to pass the data, the problematic data. Second one is basically you need to say how many number of output final data sets do you need. Here I'm just going to say it as 5. It's a default value. So for these 5, you're going to get a 5 different imputed final clean data sets at the end. That's what this means, right? And then the method is basically like for each and every column, it can apply basically a separate function. I'm going to show you guys what are the different methods that's available for you guys. So these are the different methods. So how do you run that is basically call your methods function, then pass your mice, that's your library or function name. So you need to pass this statistical function into the utility function. So you see here, so there is a bunch of different function. It has logistic regression, it has polynomial regression, quadratic, PMM, normal regression. It's like bunch of different uh, statistical functions it has. So right now I'm just gonna use logistic regression for hypertension. Since it's a binary value, I'm just gonna use it as logistic regression. Since logistic regression works for categorical data, it's gonna help us with the hypertension. Um, and I'm also gonna use a predictive mean matching for the BMI and cholesterol, right? Let's go ahead and do that. So this one I don't need it anymore, so I'm just gonna comment it out. So first argument, like I mentioned, is your data. Oops, our data is basically input, right? Input data, right? But there is a catch. So since I already transformed it, I cannot use it back again. Right? Or let's create a new data set here. Input dt2, right? So again, NHANES, right? Now enhance is going to have the unclean data set. Now that unclean data set is going to be copied over to my new variable. Before that, remember we're going to use logistic regression for hypertension. We should have done the transformation, right? So that R knows that hypertension is a categorical variable. So let's do the same thing here. So instead of this data set, now we're gonna change to this data set, because for the input data set, hypertension is already a categorical value. For our new data set, hypertension is not a categorical value. That is why we need to change it over, right? So before we apply our logistic regression, so let's go ahead and build this function right now. So first thing is your data. Second thing is your number of imputed data set. I'm just going to keep it as 5, which I'll show you all the 5 data sets that we have, and we'll choose the best from that, right? Um, So for the method, I'm just gonna make it as create a vector and say, so here I should say for each and every column, what is the statistical function that you're gonna use, right? So I have 4 different columns here. Age is a clean column, right? Age, I don't need to touch anything on the age. So I'm just gonna leave it as just like a blank quotes. And for BMI, let's use PMM, predictive mean matching. For hypertension, let's use logistic regression. For cholesterol, let's again use PMM, right? Again, there is, you can use any regression or continuous prediction function to predict the value for the specific specific not applicable values. But here, well, let's just keep it simple and use PMM. So for the first, I'm just gonna keep it as null. For second, PMM. And then for the third, it's logistic regression, log, right? So that is how it has been spelled within the function you see here. So it's, where is it? It's logreg. That is how you need to say logreg. And predict match PMM. If you want to use normal form, you have to say NORM, right? So normal form is, that's a Bayesian normal form. So you can even use Bayesian normal form for one of these variables. But let's go ahead and do PMM again here. The last parameter that this function, mice function, is going to take is your max iteration, right? So now let's say max iteration is, you know what, I'm just going to keep it as 20 right now, right? Okay, you should always have like higher max iteration so that each and every time your data set is being iterated against these different statistical function, it's going to predict a value. So the more that you have, you'll have a better predictions. So right now, I'm just going to run this command. Now I'm not going to get any error, because I would have got an error when this specific column hasn't been transformed into a factor, right? So I can show you, you know what, actually I can show you. So I'm just gonna bring it back to my enhance record set. So now hypertension is not factor or a categorical value. So if this command, right, it's look here, it's gonna show that it's trying to create the imputation, but when it comes to hypertension, it stops there, saying type mismatch, right? Logistic regression is only for categorical data. So that is the reason exactly why I'm converting this here, right? So now if I convert it and then if I run it, it's gonna run. It's gonna take some time to do the imputation. Yeah, it's done right now. So now we have asked it to create us like 5 different data sets, right? So m is equal to 5. So these 5 different data sets will be residing inside this function right now. So we need to go ahead and access those functions to see which one you wanted to take, right? So let's use a BMI column as a reference. So why I'm saying that is, we need to look into our BMI column and to see what is the distribution of the BMI column, and then choose the right data set, right? I'll show you. So I'll just put a summary command on my new BMI column to see the distribution. So run this. So the mean is 26.56. So let's make sure we're gonna get 5 different options for this data set. Let's make sure that the data set that we're gonna choose is close to this mean, right? So let's how do you get to your data set? Just call your mice imputation command, go to your child, call imp, right? And then choose your BMI. So if I run this command, I'm gonna get like 5 different options here. For my first not applicable value in my BMI, I have 5 different options. I have 29.6, 28.7, all these 5 different options. For my third index, for my not applicable, I have these 5 options. For fourth, I have 5 options. For sixth, I have 5 options. So likewise, right? So now I need to make a decision on which of these 5 values should I be, choosing on this my my data set. So how do I get that? So if you see here in your distribution in the top, so when you run your summary command, you will get a distribution of your BMI. In your distribution, if you see, the mean is 26.56. you always want to be choosing something that's close to this mean, right? So again, these are all just estimates, right? These are not the fact values. These are just estimates. So you always want to make sure the estimate you choose is like a safer estimate. So 26.56 is your mean. So I wanted to choose, I don't want to choose something that's very far away from this mean. So see here, the first one is 29.6 and it has 33 and all, 33, 35. So this is a little bit farther from my mean. Let's take a look at the second one. 28, 35. Again, I have 35 twice, so I don't want to choose second one also. Third is 27, 26, 22, 20, 26. Again, there is 30, 27.2, 26.3, 28.7. And there is fourth, which is again you have 35. I don't want to choose the fourth. Fifth is 22.5, 22.0, 30.1, 22.5, 25.5. So the third I have 130th. There is 130. Then in the fifth I have again 130 as well. So I can choose either 3 or 5. So whichever has a closest proximity to your mean is what you need to choose. So I think I can choose, comparing 3 and 5, I think I can just choose my fifth record set. It has less deviations from your mean if you think about it. So let's just go ahead and do that. So that is going to be basically the final record set, the clean record set that you will be wanting, right? So let's rename it as final clean data set is equal to, just need to run a complete command, right? Complete, and then call your imputation function, right? And then say what is your selection. So my selection is number 5. Just say 5 here and then execute it, right? And that's done. So that's exactly how you do your mice imputation. Now if you take a look into your final clean record set, see here, there is everything has been replaced. All the not applicables has been replaced to their most closest estimated values, right? So this is basically how you do the data cleaning or missing data handling using your mice imputation, right? Hey folks, so thanks so much for watching this video. If you guys like this video, please subscribe to my channel. And before I see you guys in the next video, cheers and happy programming.